Okay. Math 3, Unit 3, Section 4. So we're going to start graphing the same as normal. We're multiplying our A times our C value. Whatever we multiply together goes up top. My middle term is what I need to add to, so that's going to go down bottom. What two terms multiply to get 24x to the fourth and add to get negative 10x squared? So I'm going to write down a couple of these because I heard both answers. And if you have multiple combinations, I probably should put the 6 on the left with my smaller numbers, and or my 4 on the left and my 6 on the right with my bigger numbers. So I heard 12 and 2, 4 and 6. And now it all depends on what our signs need to be. And I know that it has to add to a negative and multiply to a positive. So does one of them have to be negative, or do both of them have to be negative? Both, because a negative times a negative will give me a positive 24x to the fourth. So the only way I can add to negative 10 is the negative 4 plus negative 6. So if it was positive 12, or sorry, if it was negative 12 and positive 2, that would add to negative 10. But we also know that if our signs are different, then it multiplies to a negative, and that's not what I want, so I'm going to cross out that one. We're going to replace my middle term with those two terms, keeping my first term the same, so x to the fourth. My two new terms are minus 4x squared and minus 6x squared. My last term is still positive 24. Okay. Why did I put an x squared with each of these terms and not just an x? Because normally I just have a single x with each of those terms. Yeah.
Because it's 24x to the fourth.
Yeah. So you want these two terms to multiply to x to the fourth and to add to x squared. So they have to be like terms with that b value. And they have to multiply to whatever your A times your C is. So now we're going to factor by grouping. What's my greatest common factor out of these left two terms? Good. X to the second power. So if I divide an x to the second out of each of those, I'm left with x squared minus 4. And I know that I could distribute the x squared and get back to my original if I wanted to check that. What is the greatest common factor on the right-hand side? 6. And because the first one is negative, we always pull out that negative 6. And that leaves me with x squared minus 4. If I pulled out a positive 6, that would have left me with x squared plus 4, and you would just want to make sure that these two match. And if they don't match, you need to change something. All right, now I have a greatest common factor of x squared minus 4. And that leaves me with x squared minus 6. How do you know when you're done factoring? Yeah, so if you were to set up your diamond, again, this big X, and you couldn't find anything that worked, then you would be done factoring. You can also tell based off of whether you have an x squared left or just an x term left. So both of these have x squared left. One of them is factorable and one is not. The one on the right-hand side is not. Why is x squared minus 6 not factorable? All right, let's try this one. Why is x squared minus 4 factorable? They're both perfect squares. So we're going to do difference of squares on this one. And when you have a difference of two terms, you want to check for difference of squares. And if you only have a binomial and that's all we can check left is the difference of squares or a greatest common factor. There's no greatest common factor from x squared minus 6, and it's not a difference of squares. But x squared minus 4 is a difference of squares. What does x squared minus 4 factor to? So let's go up to the top just to remember our difference of squares. If we have a perfect square minus a perfect square, that is the difference of two squares. So difference has to be subtraction, and they have to be two perfect squares. And that's going to leave me with two binomials at the end when I factor. One of them addition, one of them subtraction. But each of them has the square root of each of our terms. So 3x times 3x gives me 9x squared. 7 times 7 gives me 49. So knowing that for x squared minus 4, what is the square root of x squared? X. So x times x is going to give you x squared. What's the square root of 4?
2.
2. 2 times 2 is 4. And then one of them needs to be addition and one of them needs to be subtraction in order for your middle terms to cancel out. And I still have this x squared minus 6 left over. Okay, nothing else is factorable, so that is completely factored on that first example. Questions? All right, going to the right, I have 3x cubed plus 27x. What should I do first? Yeah, greatest common factor. I can factor out either positive or negative 3x from here. I'm going to factor out a negative 3x because I like my leading term to be positive when it can. That leaves me with x squared minus what? 9. If I didn't factor out the negative, I'd be left with negative x squared plus 9, which a plus 9 is not a difference, right? But now that I factored out the negative, I can see that this is a difference of squares problem. Is x squared a perfect square?
Yes.
Yes. Is 9 a perfect square?
Yes.
Yes. So the 3x is going to stay out in front, and then we're going to factor the binomial to x plus 3 and what else? X minus 3. Because the difference of two squares factors to two binomials, one addition, one subtraction, and then their terms are each the perfect square of our original factor. All right, and nothing else can be factored because these are all x to the first power, so then that one's done. Okay, we have, so remember, all of this page has a bunch of reminders on it. So if you are forgetting how to factor something, there's all of these summaries at the top of each of your factoring. Down at the bottom, it also says, remember, to find the y-intercept of a polynomial, f of x, set x equal to 0 and solve for y. The y-intercept is the point 0, comma f of 0. So you're just going to, if this was an equation, like we had y equals in front, we'd set 0, x equal to 0, and then we'd simplify for the y-intercept. And for x-intercepts, we would set each of these factors equal to 0 and solve. So we're going to do that on the other side. That's why we're factoring today, is because these are going to be in standard form, and we want to be able to graph them, and the easiest way to graph them is in factored form. Okay, so starting with the first example at the top, we are going to factor this one so that we can see how we would graph it. So my greatest common factor is x, and I'm left with x squared minus 25. Can I factor x squared minus 25? Yes, it's a binomial, it's subtraction, and they're both perfect squares. So it's a difference of squares. So it factors to x minus 5 times x plus 5. It does not matter whether you have x plus 5 first and x minus 5 second, or the other way around. So what are the different things I would need in order to graph this function? I need x-intercepts, I need a y-intercept, I need to know what direction this is going, I need to know what degree it is so that I can find out the end behavior. So just a reminder, we look at the degree to determine our end behavior, and we want to look at the leading coefficient. The easiest way to find that information is if you're already in standard form. I can find it in factored form too. I have 1, 2, 3 x's, so x to the third power. But up here in standard form, I already know my highest degree is, or my highest exponent is 3, so my degree is 3, which is odd. My leading coefficient is my number in front in standard form, in front of the highest power. So that leading coefficient is 1. What's the important information about a leading coefficient? Positive. All right, those two pieces of information help me determine my end behavior. So we are going to do the right side first. Where do I get the right end behavior? From the leading coefficient. So if the leading coefficient is positive, the right end behavior is positive. And then I get the left side from a couple different things. I get it from the right, and I get it from the degree. So if my degree is odd, what does that mean about my two end behaviors? Odd means opposite. Odd means opposite. So opposite of the right, we're going to do negative infinity for the left. Yes. Yes, that the leading coefficient is in front of x cubed. As long as we're in standard form. So you have to have the highest exponent first, and then it'll definitely be in front. All right, after that, I need my x and y intercepts. So my x-intercepts, I'm going to plug in 0 for y, and then solve for x. So if all of these multiplied together equal 0, that means x could equal 0, x minus 5 could equal 0, or x plus 5 could equal 0. Adding the 5 to the other side, I would get a positive 5. Subtracting this 5, I would get a negative 5. So those give me 3 points, which are 0, 0, 5, 0, and negative 5, 0. And we're going to plot those. Do any of them happen more than once? Any of my end behaviors happen more than once? No, where do I look to see if they happen more than once? If you apply at the same point twice, also, here's my factored form, right? What's the exponent of this binomial? 1. If it's not written, it's 1, right? So what's the exponent of this binomial? 1, and this binomial also 1. These are all to the first power, which means there's no bounces. A bounce would happen with an even power, which would be 2 or 4 or 6. So these are all going to be passes. So I'm just going to write a P next to each of these so I remember to pass through each of those points. But before I draw in my function, I want to I want to solve for the y-intercept to make sure I get that correct. Does anyone know what my y-intercept would be? Oops. Y doesn't equal the intercept. 0, 0. When your x-intercept is 0, 0, your y-intercept is 0, 0. Because you're plugging in 0 for x and solving for y, or you're plugging in 0 for y and solving for x. If you already have this one point, you know the other one. Also, whenever you have a greatest common factor of x, then we know the origin is contained in the problem. So that will always, when you have an x out that you can factor out to the front, that will always give you the origin. So now I can go ahead and draw this in. These are passes. I need to start from negative infinity and end at positive infinity. And there's my graph. So most of that was review. These next 3 problems have more of what you'll be doing in this section. So if you'll remember from Unit 2, if I have a solid dot, f dot g of x, what does that mean? Solid dot. Yeah, f of x times g of x. So my y is going to be equal to f of x times g of x, which means I write out y is equal to f of x is x times g of x. If I'm going to multiply by something, I'm going to put it in parentheses. Okay, now I have a couple different options here. Should I distribute x to negative 2x squared plus 72? No, because we're going to factor this anyway, so we might as well just factor from here. The x would, if I distribute it in, I'll have to factor it back out, and I don't want to do that. So what's my greatest common factor between negative 2x squared and 72? 2. And even more than that, I'm going to pull out a negative 2 so that my leading coefficient is going to be positive inside the parentheses here. So I'm going to pull out a negative 2, which would change the sign of everything inside. So I'm left with x squared minus what? Close. 36. 36 is what kind of number? A perfect square. So negative 2x, that factors to x minus 6 times x plus 6. All right. So that's going to give me 3x intercepts. You can probably already predict what those points are going to be. What is one of my x-intercepts? Let's start from the left. This x, what x-intercept would that give me? Is that the harder one? Let's start from the right. What x-intercept would this one give me? Negative 6, 0. We know if we... if we plug in negative 6, then that would make my whole thing equal to 0, right? So negative 6 plus 6 is 0. 0 times anything is 0. Right here, I would plug in positive 6 to make everything equal to 0. What number would I plug in here to make everything equal to 0? Negative 2 times 2 is 4. 4 times something is not necessarily 0. 0. 0 times negative 2 is 0. 0 times something is 0. 0 times something else is 0. So this one's going to give me 0, 0. Now, what did I skip? Any idea? I skipped setting each of these equal to 0. I skipped showing that your y, when your y equals 0, it'll give you your x-intercepts. Because I want you to know how to look at a factored form and determine that same answer. Because you should be able to predict what your graph is going to look like. If you're able to predict how many intercepts you have, then you can always check your answer at the end. So if you're not sure how I got any of these, please set them equal to 0 and solve. I would divide by negative 2 on each side here, and I would get x equals 0. If I set the second one equal to 0, I would x minus 6 equals 0. I would add 6 to the other side and get x equals 6. And all of these x values are paired with a y value of 0, because that's how you find an intercept. All right, let's plot those 3 points. All right, now we're going to look at the degree, the leading coefficient, and the end behavior, which you can do before you solve for the x-intercepts or after. What is my degree for this polynomial? 3. So I have an x to the first and an x squared, so I'm going to multiply those together to get 3, so an x to the third power. What is my leading coefficient? It is the negative 2. So remember, from each term, you're going to multiply your leading coefficient. So this term has a 1. This term has a negative 2 for my leading coefficient. So I multiply those together to get negative 2. All right. So if my leading coefficient is negative, which end behavior is also negative? The right-hand side. Very good. So negative infinity. If my degree is odd, is my left going to be the same or opposite of my right?
Opposite.
Opposite. So we're going to start up and end down. What's one thing that I did not write down that I need to make sure I label? Oh, pass or bounce. Yeah, these are all passes because they're all to the first power. So I want to make sure I label that each of those is going to be a pass, and I did pass through all those. And then also, my y-intercept is what? 0, 0, and that's because my x-intercept, I have a 0, 0. Or you can plug in 0 again and solve for it again. All right, so we are going to factor this next one together, and then you're going to solve. Actually, we're going to factor and set up both of these next examples in factored form, and then you're going to solve the rest of it on your own, graphing each problem. So, starting by setting it up, the trinomial on the left-hand side, so the third example on this page, how do I factor a trinomial? Yeah, that big X. So what goes in the top of my X? 4x to the fourth. And the bottom? Good. So because this is an x squared, I know Both of my like terms need to be x squared. What two numbers multiply to positive 4 and add to negative 5? 4 and 1. Anything specific about those? Both are negative, because a negative times a negative is positive, but a negative plus negative is a larger negative, or a more negative number, not a larger number. So, from this, we're going to do x to the 4th minus 4x squared minus 1x squared plus 4. All I did was replace the negative 5x squared with my two new terms. I split it. All right. Left-hand side, what's my greatest common factor? Good. Factoring an x squared out of those first two terms, we're left with x squared minus 4. On the right-hand side, what factor should I pull out? Why negative 1? Good. Right now this is negative x squared plus 4, but I want it to be positive x squared minus 4. So in order to change the sign, we pull out a negative. I have two binomials that match now. X squared minus 4 and x squared minus 1. Which of those is a perfect square? Trick question. X squared minus 4 is a perfect square, so let's go ahead and factor that. That factors to x minus 2 times x plus 2. What's trick about my question? X squared minus 1 is also a difference of perfect squares. 1. Is 1 a perfect square? What times what gives you 1? Good. So this factors to x minus 1 times x plus 1. All right, so in a minute, I'm going to have you graph that on your own. Let's talk about some things. I'm not going to necessarily write them down, but let's talk through it. What's your degree here? You can look at your very first polynomial, which is the highest degree is 4, or you can say there's 1, 2, 3, 4, x to the first powers. So yes, the degree is 4, which is even. Your end behavior should go in what directions? Same or opposite? Same. Your leading coefficient I would get from standard form, which is a 1. And that's positive, so your right side will go up, which means your left side goes up. And then you're going to find each of your x-intercepts. There are 4 of them. Are any of your x-intercepts going to be a bounce? No, because none of these binomials are to the second or fourth power. So you are able to graph that one. But before you go ahead and graph that one, we're going to set up the following equation. So please go to the next example. All right, y equals f minus g of x. What does f minus g of x mean? Yeah, you're going to subtract these two functions. So f of x minus g of x is the same thing. So I'm going to set that up on the right-hand side. We're going to take f of x, which is negative x to the 4th, and subtract all of g of x. What happens when you subtract a polynomial? Bless you. Do I just subtract negative 7x to the 3rd? Do I subtract every term? Do I subtract it in parentheses? What do I do? If you just write this one next to the subtraction sign as 7x to the 3rd plus 12x squared, this will give you the wrong answer. If you put parentheses on it, you can get the right answer, because subtracting a polynomial means you need to subtract every single term. Okay? Which means all of my signs will become opposite when I'm subtracting. So negative x to the fourth stays the same because it's in front of the subtraction sign. Then I can distribute the subtraction, or the negative, to every other term. So I get negative x to the fourth minus 7x to the third minus 12x squared. Make sure you have a minus 12x squared. Now we can factor out what? I heard x squared. Anything else? I would factor out negative x squared because it's always easier to factor a polynomial that it has a positive leading coefficient. So if these are all minus and I factor out a negative, they're now all positive. And we want to determine what two numbers multiply to get 12x squared and add to get 7x. What are those two numbers or terms? 4 and 3. 4x and 3x are the terms that I'm going to replace the 7x with. Okay, so the negative x squared still stays out to the front. That's the same as this one. Then you're going to factor what's inside the polynomial. If you have a leading coefficient of 1, you can use a short method of factoring, or guess and check would be a lot easier on this one. Those two numbers, the 4 and the 3, should be the numbers you get after you factor all this. And I'm going to show you the long way first. We're going to factor an x out from the first two terms here, and that leaves me with x plus 4. We're going to factor a 3 out from the second two terms, and that leaves me with x plus 4. So when I factor out x plus 4, I'm left with x plus 3. Do you see how the 4 and the 3 are the two numbers that I used on the right-hand side? That only works when your leading coefficient is 1. So if you want to guess and check on that, then you can. It's a lot easier. Remember that before I started factoring all of this, I had this negative x squared out in front. Actually, I don't need my brackets right there anymore since I only have parentheses. So I have a negative x squared times x plus 4 times x plus 3. So I would like you to please graph both of those equations. I'm going to come around if you have any questions.